This is 3.7 to 3.8 assignment 2, where we're graphing rational functions. So we will go through each of these questions. Number 1, it's already factored, so that's nice. Nothing cancels from numerator to denominator, so there's no holes. Zeros or x-intercepts, that they come from values of x that make the numerator equal 0. So that would be 1 and negative 2. And for the 1 here, that's multiplicity 2. So I have that written there. Under zeros, vertical asymptotes are values of x that make the denominator equal 0, which are 0 and 3. And it's a 0 multiplicity 2, which means they'll go in the same direction or kind of bounce off infinity we talked about. And then x equals 3 is multiplicity 1, so they will go in opposite directions at that asymptote. So have both of those vertical asymptotes there. Let's go back to zeros. And let's talk about our zeros here and graph them. This is at 1, multiplicity 2, so we put an x there at 1 to remind us that it bounces. And then we have another one at negative 2. We'll just put a dot. Goes through the dots, bounces off the x's. We have our vertical asymptotes drawn there. Horizontal or slant, we need to look at the degree of the numerator compared to the degree of the denominator. This gives us an x squared times and another x, so that's x cubed, x squared and another x, so that's x cubed. So the degree of the numerator is 3, which equals the degree of the denominator, which is 3. And so when that happens, your horizontal asymptote is at y equals the leading coefficient of the numerator. So if you multiplied out all those x's, you would have a leading coefficient of 1, and then over the leading coefficient of the denominator, same idea, that would be 1. 1 over 1 is 1. So you notice there I have a horizontal asymptote at y equals 1. There's no y-intercept because there is a vertical asymptote on the y-axis. So this time we have our graph has 2 vertical asymptotes, which means our graph is split up into 3 sections. And so we'll want to figure out where our graph goes. So what we can do is we can try to think through one of the sections and figure out where it can or cannot be. So over on the far left here, it could be this black part or it could be this orange part. Well, it's got to be the orange part because we do have to cross through this x-intercept. So we'll go ahead and get rid of this black part. And now thinking about this vertical asymptote here, that's x equals 0, and that was multiplicity 2, which means we kind of think it bounces off infinity or they go in the same direction. So this also has to go down. And so we're going to follow that vertical asymptote. We have to hit this 0 here, but it's an x. That reminds us it bounces off. And then it will come back down towards this vertical asymptote. The next vertical asymptote, that came from x equals 3, which is multiplicity 1, which means since it went down to the left, it's got to be up to the right, on the right side of it, and then we'll come down and get closer to this horizontal asymptote. Also notice it definitely couldn't be, I'm going to just sketch another one in here, let's sketch it green. This couldn't be the branch because it would have to go through the x-axis, and there we know that there is no x-intercept there. So there's our graph for question 1. Moving on to question 2. Already factored for us. Holes. We want to see where does this cancel. So x values that make canceled factors equal 0. What x minus 2 cancels with x minus 2. So there's a hole at x equals 2. So at x equals 2, I'm going to come to the very bottom. I'm just going to put a circle here to remind me that there's going to be a hole in our graph. once we graph, we'll see better where that hole is. But it will be at x equals 2. Next, we find our zeros. So with the remaining part, and if you want to, you could rewrite this with that canceled factor not there. And values that make the numerator 0, values of x that make the numerator 0 are negative 1 and 4. So we can, and they're both multiplicity 1, so let's go put points at negative 1. Negative 1 and 4. Vertical asymptotes at x equals negative 3. Because of this, well, I should circle here because of that, and it's multiplicity 2. And so, and then, sorry, the last thing, horizontal or slant asymptote, we look at the degrees of the numerator and denominator. They are both 3 before we canceled, so that's an x times an x times an x, which is x cubed. This is an x and an x squared, so also x cubed. The degree of the numerator would be 1. The degree of the denominator would be 1. So y equals 1 over 1 gives us this horizontal asymptote here. Y-intercept, plug in 0 for x. So I'm going to go ahead and erase some of our highlights here. Actually, let's just come to this. We'll just highlight more. So this pink highlighted part, put 0 in for x. So this would be 0 plus 1, which is 0, so that's 1. 0 minus 4, which is negative 4. So that gives us a negative 4 on top. Put 0 in the denominator. 0 plus 3 is 0. Sorry, it's 3. 3 squared is 9. So we have a horizontal asymptote at negative, sorry, we have a y-intercept at negative 4/9. So negative 4/9 is somewhere around there. All right, and now we want to graph kind of intelligently. So looking at, let's do this. Let's look at black. That could be one of our branches. Usually I've been saying our vertical asymptote splits the graph. We have one vertical asymptote, it splits it up into 2 parts. So we're going to have 2 branches. And so to the left here, it could either be this orange part, or it could be, let's go yellow, it could be this yellow part. Well, it definitely can't be the yellow part because the yellow crosses through the x-axis, and we know there is no x-intercept there. So it's got to be the orange part. So we'll make the rest of our graph orange as well. This vertical asymptote is multiplicity 2, which means these need to go in the same direction. And so comes down. Remember, we are allowed to cross through horizontal asymptotes. Kind of in the middle of the graph, horizontal asymptotes help us see what happens at the end. So we'll go through here. It will go through that y-intercept at negative 4/9. Somewhere along here, it will change direction, come back up through this one, and then follow the horizontal asymptote. If we wanted to make this more accurate, we could try plugging in 2 into our function to see how far down this goes. And now one other thing, we're not finished yet. We have this O down here, this circle, to remind us that there is a hole in the graph. So we're going to pull out an eraser. At y equals 2, we're going to erase that at y equals 2, and we're going to put an open circle to show that there's a hole in the graph there. And so there is that function. Question 3, h of x. It's already factored. Anything cancel? Nope, nothing cancels. I should say none, not none. Zeros. Zeros are values of x that make the numerator equal 0. So 3, multiplicity 2. So 3 makes that 0, multiplicity 2. And then negative 1, multiplicity 2. And so I'm actually going to remember to do this time. So they're both multiplicity 2, so at x equals 3, I'm going to put an X to remind me that it's going to bounce off there. And at -1, I'm going to put an X to remind me that it bounces off there. Vertical asymptote comes from values of X that make the denominator equal 0. Well, that's 0 multiplicity 4, which is even. So we know at that vertical asymptote, they'll go in the same direction, either both up or both down. We've also mentioned it kind of bounces off infinity. So we've done zeros, we've done vertical asymptotes. Let's look at the degree of the numerator compared to the degree of the denominator. They are both 4, so they're equal. And so we'll have y equals the leading coefficient of the numerator over the leading coefficient of the denominator. Coming back up to looking at our function here, the degree of the numerator, this is a squared and a squared, so the degree of the numerator is 4, degree of the denominator is 4. And then if we multiplied all of this out, x squared, so x times x is x squared, times another x squared with a negative out front would just be -1, and then +1, which is -1. So you see here we have a horizontal asymptote at -1. So we got that. Any y-intercepts? No, because plugging in 0, we have a vertical asymptote. So now let's think through either the left or the right side of our vertical asymptote. In this case, I think thinking through either one will be fine. And so looking to the left here, we think of the two options we could have. We could have this orange, which we have a vertical asymptote. It would bounce off here and then go back. I don't know where it would go, but it can't come down here because there's no other x-intercept. So it can't be that orange one, which means it will have to be the lower part. So it's going to have to be down here. So it's going to come up, bounce off at that 0, and then get closer and closer to the horizontal asymptote. The vertical asymptote was multiplicity 4, which is even, which means to the right of this asymptote also needs to go down. And then something similar will happen. It will come up. It will pass through the horizontal asymptote, because horizontal asymptotes just tell us what happens at the end of the graph. It will bounce at this x-intercept or 0, and then it will click closer and closer to that horizontal asymptote.